Hey guys, what's up? I hope you are doing great. Back with another video, and in this video we are going to discuss complexity analysis. So we'll discuss time complexity, space complexity, and then I'll give you a brief overview of how you can predict whether your solution is gonna get a AC or if it's gonna get TA lead or ML lead on the various platforms like Lead Code, Code Forces, CodeShift, CSS, etc. And finally, we are gonna discuss one of the most discussed doubts, that why is your solution failing even though it has a better time complexity, and your friend might be having a solution with a worse time complexity and it's still passing. Obviously over here when I'm saying time complexity, I mean the asymptotic notations. So with that, let's go ahead. I could actually teach you the theoretical part, but that won't be really useful for a DSA CP. So I'll rather teach you the practical part. I'll tell you how time complexity is actually calculated on the online judges. Obviously this won't be helpful for your academic purposes, like it won't help you in the exams itself. So for that you'll have to prepare separately, but this definitely is going to help you for online assessments, for coding, and for such related things. So with that, let's get started. Let's start from the very basics. Let's say I ask you that you have to take input from the user and then print it. So you can write a very basic function like this, or a very basic code like this, and you can then run it. Let's say the input is 12, we expect the output to be 12, and yeah, we get it, right? Now I ask you that how long does your program takes to execute? So what you can actually do over here is, like from a layman's perspective, you can say that, okay, I have three statements over here. I have an int n equal to 0, then a c in n, then a c out n, then a return 0. So maybe every statement is gonna take some time. And let's estimate it to be maybe like 1 second. Obviously this is not correct, but let's estimate that it's 1 second or 1 milliseconds. And then you'll say that, okay, there are four statements. Every of those statement is taking 1 millisecond. So maybe the time complexity is 4 milliseconds. And then you'll say that, okay, your program is going to take 4 milliseconds to run. That's fair enough. But now let's change the program a bit. Firstly, take input n from the user, input n, and then take n integers, right? So n is basically the size or the number of integers you're going to accept from the user. So this would essentially remain the same. And over here inside of a loop, you can say from 0 to n, and then you have to take a variable from the user, let's call it a, and then you can print it out, right? Let's say you take 10, okay, let's say you take 10 inputs, or maybe like five inputs, 1 2 3 4 5. So now you would expect that the program would return you 1 2 3 4 5. Let's just write that over also here. Okay, that's fine. Let's run it. Yep, that works, but yeah, spacing is different, so hardly matters. Anyway, cool. So with that, what we understand is that once we did this, then our complexity is now dependent on whatever value the user would provide us. Like right now, the user was providing us with 5 inputs. So we can say that the input was 5 that was provided by the user. So we can say that this particular loop is going to run 5 times. And inside of this, we have 3 statements. Although when we unroll a loop, there are actually more operations that are going to be performed. For example, I++ over here, a conditional check over here. But ignoring them, we can say that we have 3 statements that are present inside our loop. So the time complexity would be 5 into 3 plus something, plus basically these 2 statements over here and this one statement over here, so plus 3, right? But now what can happen is that it's not necessary that the client or the user is gonna give you an integer 5 itself. It could be maybe like 1000, right? Or 10,000, a million, a billion, anything. So because of that, this now becomes a variable, right? So if you look at the program, the time complexity is more or less fixed, except for this particular variable, because as soon as this changes, the number of times the loop is going to get executed is also going to change. So now our time complexity is dependent on this particular variable. So if we want to keep it that way, so we can say that the time complexity is n into 3 plus 3, right? Now since everything else is a constant, hence it won't affect our result that much. Now what do I mean by that? For example, your n is, let's say, 10, right? So the time complexity would become, or the seconds it takes to run the program vaguely would become 3 into 10 plus 3. That would give you a 33. But let's say now your n is 1000, right? So the time complexity would become 3 into 1000 plus 3. That is 3000. Okay, yeah, 3003. So also for a million, it would become 3,000,003. So what you see over here is that the constant is not changing, right? Constant obviously won't change, but the value of n is changing your answer drastically. So our main focus should be on n itself. Or we can say that the time complexity of our program is order of n. So as the value of n increases, our program would actually take more time to compute. So we'll say it's order of n. Now what could essentially happen over here is that I can say that, okay, there's a loop inside of a loop. So let's say there's another variable and it's also going to n, right? Now what would be the time complexity? And let's say this particular operation that we are doing over here, it's being done inside of it. Now because of this, what happens is that you'll say that, okay, this loop, this outer loop is gonna run n times. Okay, n times, right? Also, each time this outer loop runs, the inner loop is also gonna run n times. So this is also gonna run n times per outer iteration. So essentially, the number of times these statements are gonna get executed becomes order of n square, right? Because for each of these iterations, this get executed n times. So n into n is n square. So now your time complexity would become order of n square. I hope that makes sense and it's not really hard to understand. So what can be other kind of operations over here? So you can say that, okay, maybe like you have multiple loops. Okay, let's say the same loop is being repeated again and again. Now what would happen in this case? So you can say that, okay, this is taking n time. This is also taking n. This is taking n. This is taking n. So it's actually happening 4 times, right? So this is in totality, it's taking 4 into n time. 4 into n time per iteration, per outer iteration. So the answer becomes n into 4 into n, right? Or 4n square. However, since we said that we are not really interested in the constant factor, so we can ignore this. So we'll say that the time complexity is n square itself. But now, how does this information helps us to predict how long our program is going to take? So as a rule of thumb, you can say that a computer or the online judge, because you're not going to run the program locally, right? It's going to run on an online judge. It can perform around 10 to power 7. Okay, 10 to power 7 to 10 to power 8 operations per second. So for convenience purposes, you can say that each of the statement can be considered to be an operation. So as we said that, okay, this doesn't matter, like the constant factor is not mattering. So we can say that if your n is, let's say 10 to power 3, right? So what would n square be? So n square would become, okay, let's just do that on an iPad. That would probably make more sense. So now let's say your n is 10 to power 3. So what would your n square be? So n square would become 10 to power 6, right? 10 to power 3 into 10 to power 3 is actually 10 to power 6. Now what we told us that a computer can perform 10 to power 7 to 10 to power 8 operations per second, right? So yes, we can say that it's gonna work. What if your n is 10 to power maybe like 5? Then your n square becomes 10 to power 10. But we say that 10 to power 8 operations can be done in a second, right? So in order to do 10 to power 10 operations, it will take how many seconds? That would be 10 to power 10 divided by 10 to power 8. That leaves us with 100. That is like a minute and a half or almost 2 minutes. So just less than 2 minutes. 1 minute 40 seconds to be precise. So obviously this would give you a TLE because your online judge wants that your program executes within 1 second, or at times it could say that, okay, your program can execute within 5 seconds. These are like, this is the limit I've generally seen. When we'll talk of specific platforms, we can discuss this in more detail. But generally I've seen the limit between 1 second to 5 seconds. Now, given this information, we can come up with the valid algorithms or the valid complexity of algorithms given certain constraints. For example, I can say that if your n is, less than or equal to 25, then an algorithm which has a time complexity of 2 to power n, that would get accepted, right? Similarly, if your n is less than or equal to maybe like 100, then n to power 4 would be accepted, because 100 into 100 to power 4 is essentially 10 to power 8, and we just learned that 10 to power 8 operations can be done in a second. So if that's the case, then this would pass. So for n less than or equal to 100, n to power 4 seems to be correct. What if n is less than or equal to 500? In that case, n cube should pass. Just to verify this, you can say it's 25 into 25 into 10 to power 6, right? So yeah, that would probably pass. That would be 10 to power 8 somewhat. So yeah, that would pass. Similarly, if your n is less than or equal to 10 to power 4, then n square should pass. That is something we just learned over here. Yeah, we were taking 10 to power 3 over here. Similarly, if n is 10 to power 4, then n square would become 10 to power 8, which should also pass because that can be performed within a second. Also, if your n is less than equal to 10 to power 6, right? In that case, n square would fail, right? Because n square would essentially become 10 to power 12. That would mean 10,000 seconds, which is something that would obviously TLE or give you a time-related exceeded error. So what algorithm could work over here? So something like n log n would work, because essentially when we are saying n log n, so the n factor would give us 10 to power 6 multiplied by log of 10 to power 6. Log of 10 to power 6 is somewhat 20, right? Roughly 20. So it becomes 2 into 10 to power 7. That is still acceptable. So this would work. What if n is less than equal to 10 to power 8? So in this case, order of n would work, right? Order of n still might work. Now, if your number of operations inside the program is too many, like for each iteration you're doing a lot many operations, then it might fail. But in general, for 10 to power 8, order of n should work. But now let's say your n exceeds 10 to power 8. What would you do in that case? In that case, you can say you need an algorithm that works in order of 1 time, right? So maybe like I give you a value n, that could be maybe like 1 trillion. And for this value, you have to compute some results. That could be anything. But if your algorithm takes order of n time, right, then it will have to do trillion of operations. That essentially is 10 to power 12 operations, which obviously cannot be performed. Hence, we can say that the answer should come in order of 1. This basically means that your algorithm should not actually be dependent on the input itself. Like whatever may be the input, your algorithm does certain number of steps, certain fixed number of steps, and it computes the output. Let's take a small example over here. Now, what if I say that I'll give you a really big number, it could be up to 1 trillion, and you have to tell me if it's odd or even, right? In that case, what you actually need to do is take the input from the user and check for the last number. If it's odd, then the number is odd. If it's even, the number is even, right? So it's order of 1 operation, right? So such algorithms can also exist, and which are actually not reliant on the size of the input of the. Is there such other algorithm that also exists? Yes, there's something order of log n. For instance, we write a certain algorithm in which there's a while loop, and inside of this loop, a number gets halved every time. So n is equal to n divided by 2, and this runs till the time while n is greater than 0, right? Now in this particular loop is definitely dependent on n, but it's not linearly dependent on n. Reason being that your n is getting halved each time, it's not getting decremented each time, right? So what eventually would happen is, let's say your input for n was 1024, right? So it becomes 512 in one go. It becomes 256, then 128, then 64, then obviously 32, then 16, then 8, then 4, then 2, then 1, then 0. So in this case, what we see is that the number of operations required over here were actually 1. Let's mark them with a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So in total, 12 operations were required for input of size 1024. Even if I increase it by several times, let's say I make it 10 to power 9, even then 30 operations would be required. 30 or maybe like 40 operations. So these kind of algorithms would run in order of log n complexity, right? Now running in order of log n means it's extremely fast, and most likely, no matter what kind of input you are having, your program is gonna pass. And this definitely is one of the fastest algorithms you can build. Obviously, nothing beats order of 1. But if it's not order of 1, then order of log n is one of the best time complexities you have. Now someone would comment on my video that, okay, no, order of log n is best, or order of log n is best. I'm not going into that detail. I'm just talking about the basics in this video. So I hope this particular part is clear. And now we can discuss about how space complexity is calculated. So let's understand that also by an example. So let's clear this up. That's a lot of mess. All right. Now I say that, okay, in the program itself, you have to save the values too. So what you can do is, you'll say that, okay, I'm going to take an array. So int rn, right? And then you are going to save the values over here. So you are going to take the input from a user, or you can just directly take the values in the array itself. So you can say array of I, right? Now over here, the thing to note is that we already discussed that time complexity is going to be order of n, but the space complexity is also now order of n because we are having an array that's taking n number of elements. So its size is also dependent on n. Now let's see how would this work. Like if I have n elements and let's say n is 10 to power 6. So how much space would it demand from the OJ? So for that, we have to understand that each element of this particular array is going to demand some space from the OJ. Let's say each element demands 4 bytes of space. 4 bytes of space. And we have 10 to power 6 elements in total. So it will demand 4 into 10 to power 6 bytes. A kilobyte is 1024 bytes and then a megabyte is 1024 kilobytes. But let's just say for the convenience purposes that it's exactly 1000 bytes. So you can say this becomes 1 megabyte. This right over here becomes 1 megabyte. So in total, it's taking 4 MB of space, right? But what would happen if our data type changes? Now, maybe instead of int, we are taking a long. That is definitely something we can do. So all of that would actually vary our answer because maybe like when the data type changes, I'll have to change the size of each element from 4 to 8. In that case, it will become 8 MB. But now you're seeing the same trend over here as well, that the majority of it or the biggest factor that's going to change the size of the array is actually n itself. So similar to time complexity, we also denote the space complexity in terms of order notations, or we can say it's order of n or order of n square log n, etc. So with that, I think the space complexity and time complexity is done. And with that, we do have a basic understanding or a basic clarity of how time complexity is calculated. So we can try to understand that what kind of informations OJs provide us or the online judges provide us by which we can decide that whether our program is going to pass or fail. So for that, let's open Codeforces. And on Codeforces, I'm going to specifically mention a difficulty level of 8000 to 1000. And let's pick up a problem now. So let's pick up the first problem itself, that is least product. Let's open this problem up. And over here, the problem states that t is up to 500 and n is up to 100. Now for n up to 100, what are all the algorithms that would pass? We just studied that for n up to 100, maybe like n to power 4 would be fine. But would it be? Now this is one of the noob mistakes that can be made when you first study algorithms, because what eventually would happen over here is they're also mentioning a t, right? Now t is up to 500. So for each of the test cases, if I give you n integers, so that would eventually become 500 into 1000, that is 50,000. Now with 50,000 data points, an algorithm that is n to power 4 or n cube, anything would fail, right? So essentially over here, your algorithm needs to be n log n or order of n. Some more information that is often provided in Codeforces is the time limit per test case. So it tells us that the time the OJs would allow your program to run for each test case is actually 1 second. And we just studied that, okay, 10 to power 8 operations can happen in 1 second. So we have to keep that in mind while calculating the complexities or calculating the probable or potential algorithms that could pass. Also, memory limit is 256. So keeping 256 megabytes basically means that we can have around 10 to power 6 elements in our array or whatever data structure we are going to use. So yeah, Codeforces is one of those platforms which provides you with all the information you'll need. Similarly, even on CSCS or on Codeforces, you'll find this relevant information. For example, yeah, for Codeforces, if I open this program, so they mentioned that the time limit is 1 second and the memory limit is 1.5 gigabytes. So obviously you have this information in mind, and whenever you write an algorithm, even before submitting and getting a TL lead or ML lead, you can actually observe the complexity of an algorithm and can have a fair idea of how long it's gonna take to run on the system. So even on CSCS, at the top, you'll be able to see the time limit in which your program should run and also the memory limit which the OJ is gonna provide you. But one platform is a bit different, that is LeetCode. Now, if you look at LeetCode, it does not provide any such information. For example, this, I guess, is the daily challenge of LeetCode. Now over here, it has not provided us with all that relevant information. Yes, it provides us with the constraints that, okay, the value of n or the number of inputs is going to be that much, but it doesn't provide you with the time limitations or the space limitations which the OJ would incur on us. So over here, we can have a similar mindset that, okay, 1 second is going to be fine. And we are also going to have a memory limit that would be somewhere between 256 MB to 1 GB. This would almost always hold true. And with this assumption, you can go ahead Also, when I say that 256 megabytes or 1 GB is gonna be fine, the number of elements you're gonna save inside of an array or any data structure should not exceed 10 to power 6 or 10 to power 7, because if that happens, then you probably are playing on thin ice and it becomes really easy to get MLE'd itself. So yeah, that's how these three platforms work, and I hope that helps. So with that, let's dive into the very last doubt, that why is it that sometimes a asymptotically correct solution from your side does not pass the OJ, but maybe your friend is submitting a far worse algorithm and that passes. So we'll have to take an example for that. Let's say you made an order of n square algorithm and your friend over there made a n square log n algorithm. Also, let's say the size of the input provided was 4 into 10 to power 3. So essentially the number of operations your algorithm would have to do is 4 into 10 to power 3. That essentially becomes 16, okay, into 10 to power 3. That essentially becomes 16 into 10 to power 6. Or you can say 1.6 into 10 to power 7. And similarly, your friend's algorithm will have to do 4 into 10 to power 3 or 10 to power 6 into log of 4 into 10 to power 6, which becomes 16 into 10 to power 6 into somewhat 20. So this becomes 3.2 into 10 to the power 8. Now you'll say, how is it even passing in the first place? Because 3.2 into 10 to the power 8 is, fairly big value. But that 10 to the power 8 operations per second is actually a estimation. And it could also happen that the program allows maybe like 3 seconds or 5 seconds of runtime. So, but the main problem is like, why is your algorithm failing, which is 1.6 into 10 to the power 7? Because that definitely is better than that. It's even 20 times better than that, right? At least 20 times better than that. So why is your algorithm failing? The simple reason is that when we said that the constant factor is gonna get neglected, so it could have been the case that you were using a for loop inside of which you had multiple number of operations, right? For example, let's just move here. Let's say this was your for loop. And since we are saying n square, so maybe like there was a for loop inside of that as well. And inside of this, maybe like you had an int x, then int y, int z, so on and so forth. And after that, you could have done several number of computations, or maybe like y is plus equal to x or anything. Let's say the number of operations here were x, capital X. Now what would happen is that this x needs to be multiplied with an overall time complexity, which we often neglect over here, like we just said, right? So let's try to multiply this. So your space complex or your time complexity becomes x into 1.6 into 10 to the power 7. Let's call it x1. And your friend's time complexity is x2, where x2 is the number of operations he has to do in his for loop. X2 into 3.2 into 10 to the power 8. Now taking a hypothetical scenario that in his for loop, he's just doing a single operation. So this would become 1. So the overall time taken would become 3.2 into 10 to the power 8. And guys, I obviously know that it can't perform just one operation inside of a loop itself, because it's going to unroll and there are going to be multiple operations, but I'm just giving a small example over here. Please don't call out me for this. Cool. So with that, and let's say your x1 value was pretty high, maybe like 30 or maybe like 50. So let's say 30. So with that, your time complexity becomes 4.8 into 10 to the power 8. Now, in this case, the time taken by your friend's program to run would be less than the time taken by your program to run. And the OJ does not know the asymptotic time complexity of your algorithm. People feel that the OJ knows that, but the OJ doesn't. OJ doesn't cares about that. The only thing OJ does is, or the online judge does is, it runs your program for some particular inputs and then tests that how long does it takes for your program to complete. That's all OJ does. And when it will run your program, it will take it more time than compared to your friend's program, and probably it's going to give you a TLE. Now this is one of the reasons you get a TLE. There are more reasons. Like sometimes you might miscalculate your algorithm's complexity. For example, a lot of people use unordered maps and they feel that the time to look up in an unordered map is actually order of 1, which is not the case. Because what happens in case of an unordered map is that in case of collisions, now what is collision is a different topic altogether, but I'm not going to discuss that in this video. We'll discuss that probably in some future videos. But in case of collisions, the time becomes order of n. Now with order of n, your algorithm is probably gonna fail. Now such things, when they are ignored, the time complexity analysis is badly ruined, and hence the OJ ends up giving you a TLE. This is one of the prime factors of it. What are the other reasons? Now, the other reasons are also related, like your x1 value is always going to be x2 greater than the x2's value, or the constant factor of your algorithm is going to be greater than the constant factor of the other algorithm that might actually be inferior in terms of time complexity or asymptotic notations. However, one of the other things is, let's take two examples over here. For example, you have arrays, and this is specific to C++, but you will find similar analogies in other languages as well, and vectors. Now, both of them offer you a order of one lookup time. However, in case of vectors, the constant value that's added over here is far greater than that of arrays. Let's say, again, it's just an example, not the exact values. Now, let's say vector is having maybe like 5 milliseconds to retrieve any one of the values. Whereas in case of arrays, this value is definitely going to be lower. Now let's say it's 2 milliseconds, right? So if all the operations are array dependent or vector dependent, in that case, even the same algorithm done with a vector is going to be 2 times slower or 2.5 times slower compared to an array, right? So these all things do make a lot of difference and are often ignored. And that's the reason you end up saying that your algorithm, which is asymptotically correct, ends up giving you a TLE. Now, obviously guys, I won't be attaching any problems in the description of this video because this is more of a concept that's going to help you in the future. And obviously there aren't any problems which you can solve by learning these concepts. However, I'll be providing you with a blog of code forces in the description section that should probably help you to understand this concept better. Also guys, if you have any doubts related to this video or related to any other video, then please let me know. Also, please feel free to like or dislike the video based on if you like the content, or if there are scopes of improvement, feel free to drop down a comment in case you feel you have some suggestions which could help me improve. Thanks a lot for sticking till the end. Bye bye.